Welcome to another presentation about the use of artificial intelligence in detecting and preventing breast cancer. This is the order we're going to follow. We're going to have an introduction. We're going to talk about the environment and the agent of the program. We're going to talk about the data set being used and how it's going to be used. We're going to talk about an informed versus an uninformed search. And we're going to talk about accountability and in artificial intelligence. So once again, when cells develop abnormally, it leads to the formation of tumors. And when these tumors are sick or cancerous, it leads to the development of cancer in a particular body part. In this case, we're focusing on breast cancer that develops mainly in women, but sometimes can also be found in men. So when a tumor develops, it's really necessary for it to be detected as either cancerous or non-cancerous so that the spread and eventual development of it into cancer can be stopped. But most times this detection is not very efficient with normal physicians, and so the use of AI is brought in to make it more effective and efficient. So an environment is basically a problem to which the agent is a solution. The environment is the space or the area within which the agent works. But because the environment is the one from which the agent perceives and it's to which the agent is supposed to react or act, it poses as a problem to the AI program. The agent is that's which acts. It's simply what acts in form in reaction to whatever it perceives from their environment. So in this case, our agent is the program that's going to be used to detect that a particular cell or tumor is cancerous. The environment that we're following has these qualities: a single agent, fully observable, it's known, discrete, and static. By single agent, we mean it's the only one acting within that environment. We don't expect there to be any other agents or corresponding organisms working in this environment. It's only the program itself there to detect whether a cell or a tumor is cancerous or not. Fully observable, it means that the agent perceives or receives all the required information that it needs to detect, to make the classification that yes, this is cancerous, this is not cancerous. If it were partially observable, it wouldn't be able to perceive all the required information, and in that case, it would need maybe uh, uh, an internal state. It would need an internal state. It need to maintain an internal state of the environment from its previous percepts. Otherwise, it will be inefficient. But in this case, the environment is fully observable. Known, an environment being known means we know all its physical qualities and aspects. And yes, we do know all the qualities and the properties and the attributes that are required to work within this environment. Discrete, discrete means it's defined. It's defined. The opposite of discrete is continuous, but this environment is not changing. It's not, nothing's coming in, nothing's going out. It's just the agent classifying whether a cell or a tumor is cancerous or not, based on the data that it's been given. And since the data is sufficient, it's fully observable, the environment is discrete. And with that leads me to letting you know that it's static and it's not dynamic. Static is opposite of dynamic, and the environment doesn't change. Nothing's moving. Static data, simple. The data set is numerical. Now, how this program is going to work is it's going to base on multiple features of cells. Cells that are cancerous have different physical dimensions from cells that are non-cancerous in terms of perimeter, area, texture, concavity, the radius of them. There are so many features that we're going to use. These are just some of the few, and those that belong to cancerous cells are way different from those that belong to non-cancerous cells. And first, we're going to get a group of classified or labeled data. The label data will know that this belongs to a group of cells that are cancerous, and this belongs to a group of cells that is non-cancerous. And we'll use that to train the model so that the model learns that this is what cancerous cells look like, and this is what non-cancerous cells look like. And after training the model, it will be able to use what it has learned to determine whether a new cell in question is cancerous or non-cancerous. Moving on, the informed search. Uninformed search is whereby the algorithm knows how far it is from the goal. An example of an informed search is a graph search. Those of you familiar with graphs, there's something known as weighted graphs, whereby the distance between nodes has a particular value, say a distance basing on, let's say, a problem of distance between cities, or the energy it takes to move from one node to the next. So with that, if an algorithm were asked to reach a particular node within a particular number of steps, it knows the target number of steps. The other example is the greedy search. The greedy search is whereby the solution is built step by step, and with every step, the program chooses the next best thing. It knows the goal, but it's going to keep picking the next best thing until it reaches the target. In this model, we're going to use an algorithm known as case nearest neighbors. And in case nearest neighbors, we develop a plot. The plot looks like this, and we'll classify between, say, cancerous cells and non-cancerous cells, so that when you bring in a new cell in question, you calculate. It works by calculating the distance between the distance to the nearest group. So if it were nearest to the green group class B, then it would be classified as cancerous. If it were nearest to class A, then it would be classified as non-cancerous. So the goal is whether it's near class A or class B, and with that, that's how we would be able to use the informed search, since the algorithm would know what the goal is and how far it is from the goal. How we're going to apply the uninformed search. The uninformed search, the algorithm doesn't know how far it is from the goal. It just computes and calculates and keeps moving. The easiest example is a breadth first and a depth first search. These two types of searches, the algorithm knows what it's looking for, but it doesn't know how far it is or whether it exists. It's just going to keep going regarding the breadth or the depth of the data set until it finds. It's just going to keep searching and searching and searching. If it reaches the end, then it's not there, but it won't know how far it is from the goal. And in this program, in this model, we're going to use a technique known as dimensionality reduction. Dimensionality reduction is a technique. It's a form of unsupervised learning, whereby a data set is trimmed or pruned in order to remove unnecessary information or extraneous data. So the dataset might prove to be too large, and some features might be unnecessary. Yeah. And so when you feed it to the program, it will be able to make its own analysis on top of what you have labeled the dataset. It will be able to make its own analysis, and it will determine what actually affects a cell being cancerous or non-cancerous. So maybe the radius doesn't change, maybe the texture of the cells doesn't change, and so such data will be removed because it doesn't change whether the cell is cancerous or non-cancerous. And so using up that extra computing power to analyze useless features becomes a waste. And so that's how we use the uninformed search, because the algorithm won't know beforehand what it's going to remove or what it's going to alter. It's just going to go in, do a full in-depth analysis of the data set, and then decide what to remove. Accountability in AI. So when an organization or an individual develops an AI, it's their job to take full responsibility for the actions or the results of the AI, in that if it makes wrong decisions, the developer is the one to be is the one to be held accountable. In this case, since we're dealing with human life, we're dealing with something very critical. We, the developers, are to be held accountable in case a wrong diagnosis is made by the AI. And yeah, the system is required and expected to produce accurate results, and otherwise, we're held accountable. These are some of the references I used to make this presentation. Thank you and see you next time.